right, in this video I want to talk about some of the deployment architectures that we're going to typically see with relational database management systems. Now, the RDMBSs can be deployed in a number of different ways, and the deployment architecture is going to be driven by the needs of scalability and availability, and we do have a lot of options here. We have everything from a single non-dedicated server where you're running multiple things on it in addition to the database, to many dedicated servers where you have a cluster of database servers. So you can have a single server or many servers. And typically communication is going to be done over a network WebSocket. So this is important. When we start connecting to the database, you're going to see this in play. So you're going to see a network address or a local host and then a port name. Like if I remember right, MySQL is 3306. So that is a number that identifies a socket. So that's very typical. And often the client or the thing that's talking to the database is going to need something called a driver. So that driver is going to be specific to the database that you're using. Like if I'm using Oracle, I would need an Oracle driver to talk to Oracle over that network socket. So that communication layer is absolutely proprietary between the databases. So that is a specific thing for the databases. So take a look at the simplest thing, a simple non-dedicated server. So I have a single server. It could be I'm using server in air quotes here. It could be your laptop, your home computer, or a virtual machine running up on Amazon as a server. So just a single machine. The Relational Database Management System is installed on the machine. User logs in and accesses the database from the command line. So all the major databases have a command line interface that you can log in, get to the command line, and access the database. So that's like the simplest thing that we can do for talking to it. Often you're going to go over local host and a network socket, and I say often because there are variants to this. There are local communication net protocols when you're talking on the same system for inter-process communication. I'm not going to run down that rabbit hole because it does vary between operating systems. Just want you to be aware of that. So this is like the absolute simplest thing. Now let's take something that's also very popular, and this is a very common setup, and this is called the LAMP stack, and this is just one example. And LAMP is very popular. LAMP stands for Linux, Apache, MySQL, and PHP. I would have to venture a guess and say probably 70% of the websites out there are running the LAMP stack, just because of WordPress is the most popular web hosting software or website hosting software. Springframework.guru, that is a WordPress site. It is running on a Amazon image, EC2 instance, so a virtual machine up on Amazon. It is running Linux and the LAMP stack, and the database is right on that machine. So just a single server with the database installed. Apache is on it, and it serves up web pages. And often your application, if it's just a website, is not going to outgrow this. I could probably quadruple the traffic on Spring Framework Guru and still not need to upgrade that database. So there's a lot of headroom there. The downside is what's happening here in this scenario is Apache and the database, the MySQL software, are competing for the limited resources of that database server. Now let's take a look at, it's called client server. This was a big buzz in the 90s. I remember 90s when I entered the industry, dating myself a little bit. But that was like all the buzz. Everybody's like moving away from mainframes, and we had to go to client server. So that was like cloud computing today. So the basic concept was to move the application code to a client and different hardware. So that became the client as conceptually, while we used a dedicated hardware for the database server. So it was splitting that application load off the server, that limited resource of the server that was running the database. And it was a way to achieve scalability, and you still see this used quite a bit in some form. So it's a concept that really hasn't gone away, but you don't hear it called client server too often anymore. But the concept stays the same, where you have an external client running its own application code and then talking to a dedicated application server. So let's look at that last slide here. In the LAMP stack here, if I wanted to scale this out further, let's say I'm running against system resources, I could move my database to a separate server, and now I'd be running an air quotes client server. Let's go ahead here. Now talk about scaling client server. What it does here is give you the opportunity to scale it. And as we were going through the .com era and when the .com boom, this became a very popular way of scaling out e-commerce sites where you could take your application servers and load balance that internet traffic across the application servers, and they became responsible for serving up the web pages and doing session management, all that stuff that you need to do on an e-commerce site. So you'd have a small server farm of application servers, and then you'd have a dedicated database server. And sometimes that database server can get quite large. And often as you scaled it up, you would actually take the storage and dedicate that to, call it NAS, Network Attached Storage. And so you'd awfully load just all the I/O management to dedicated hardware. So this is a very, very scalable architecture. But that database server becomes the single point of failure. And you can get mainframe-like systems for that database server, and they run into the hundreds of thousands, millions of dollars for the single database server. So they're crazy huge. But in this type of architecture, it does give you a very highly scalable system. Now, what if we want to take this even further? So then we start looking at database clusters. So now we can scale out the application tier and then apply a similar concept where we start using multiple servers for the databases. So an example is Oracle RAC, or Oracle Real Application Clusters. Improves scalability over a single database server. And also we improve reliability because now we can lose a database server out of the cluster of servers, a node, a single server that can fail, and the system will keep running. Just like in the application tier, if one of those systems fail, the load balancer just stops spreading load to it. So very scalable, very redundant system. And then I have a mainframe-like performance. So for people that remember the good old mainframe systems that run like airlines and stuff, that were like multi-million-dollar systems and had crazy computing power. This is a very scalable architecture and very reliable architecture. And it's very, very common. And to be honest, this is probably going to get you scalability for 95% of the use cases out there. But what if we have to go even higher? So I'd call that cloud scale. And think about like the Amazons. Amazon did like 45% of Black Friday sales last year. That is insane. But Amazon runs multiple data centers around the world. Same with Google and Facebook. They all have dozens of data centers, and these data centers have tens of thousands of computers in them. They have these crazy load balancings. And that is going into what's called distributed computing, where the load is spread across many, many servers. Typically, you're looking at the cheapest commodity server. I've talked to guys that they don't even bother putting in a redundant power supply in. They buy the cheapest hardware they can. If it fails, they just pull it out of the rack, throw it away, and throw a new one in. Sometimes they don't even try to fix it. But large mainframe systems are absolutely avoided because they don't want a single point of failure. And by a single point of failure, if a mainframe's in a building in a data center, that is a single point of failure. You could lose that data center. So these are truly distributed systems. A Facebook could lose a data center and you would never even know it. It would just continue on running. Same with Amazon. They could lose multiple data centers. You wouldn't even know it. Just keep on going. In this type of situation, relational databases are not used. This is a hugely different paradigm shift from client server because you are looking at distributed computing. This is a huge shift, and I'm going to keep this outside this course. We are looking at SQL and looking at relational databases, so we are going to stick within that side of paradigm. But this is a fun topic, but probably looking at the top 3 to 5% of use cases that need to get into this.